It's all a bit cosy in here, isn't it?
Yeah.
You've got Dan the man, Dan Bryant. Last seen here April last year. You've been curiously absent. Missing in action, or in action, as the case may be. Yeah. And sitting bitch in the van, of course, we've got Linda. Stuck in the middle. And we are going to be doing something half interesting this morning. Only half interesting. I can't offer you full interest.
No, it's probably interesting.
We're going to be installing the Savo 1000. You passed me the Savo 1000 there, Dan. It's just on your side. It's connected to that LED strip at the moment. Such fine assistance. You wouldn't be such a fine assistant, would you? This is it. We'll see more about it later on, but it's connected to an LED strip at the moment. We've got a couple of elderly people who perhaps are a little doddery on their steep staircase, and they want the stairs to illuminate when ascending or descending. And it's how one controls that illumination, automates that illumination, so that they don't have to push switches, and we don't have to worry about switches at each end of the stairwell and that sort of thing. And of course we could do that with something like just a PIR, but where the fuck is the fun in that? Eh? Where's the fun in that? So I'll tell you what we're going to use. We're going to use a couple of intruder alarm sensors. However, intruder alarm sensors are a bit poor for the job. I have done this once before, back in 2019, same circuit. It's still in use today, still doing its thing, so I know it may be a little amateur, but certainly robust enough. But we are going to put this automation in today and wow these elderly types.
This is amazing. You're quite clever. I didn't know you could do things like this.
I assure you that proper electronics engineers...
would poo-poo this.
Yeah.
That's a little breadboard, and you've done all little soldering things on the back. It's very sweet.
Well, while we trundle to the job, why don't you assholes have a look at how this fucking thing works, and then we'll go and install it and see if it works. If we want to automate a LED strip to illuminate the stairs in order to prevent some poor fucker from falling down them, or to light their path of their tumbling as they do career arse over apex, then we perhaps have three options. Number one, use normal 230-volt PIR sensors, perhaps one at the top of the stairs, one covering the bottom, and both linked to the LED driver. Pros, easy to wire up and doesn't take much thought. Cons, they can be a bit clunky, and 230-volt wiring has got to be run probably a 6243Y 3-core for line, neutral and switched, which can make for something that's all a bit cumbersome and fuck ugly. Number two, use a couple of wireless sensors, as these can tell a receiver to switch on when movement is detected and to switch off a short while afterwards. Pros, no cables to pull in. Cons, someone's got to replace the batteries every so often, and seeing as we're looking to install a solution that just works without our customer having to get to grips with fiddly things like coin cells in the future, these may not be the best idea, although it appears they've been discontinued anyway, which comes as something of a surprise, and brings us on to number three, which is to use 12-volt intruder alarm sensors. Pros, thin comms cables can be used, and should we need to bury them in the walls, we need not soil our trousers over zoning any of them, as it's all extra low voltage, being just 12 volts DC. Happily, our LED tape is also 12 volts, so the same driver can also run such sensors. Cons, well, there are a couple of headaches with this harebrained ham-fistedness that's going to involve some amateur electronic shenanigans. So first, a disclaimer.
All you electronics muffins, look away if you would, else this amateur nonsense will make you shit blood. It's no Steve, Mike, Stevie, Scott or Krystal live, as sure as rat shit ain't no big fucking cry. But hey, it works, it's cheap, and it turns out just fine. So it's up to the pub for some serious drinking time. For those who love and scoff, cause they could do it better, please accept a CQ and one other letter. In fact, I'll wager despite your furious frown that the Savo 1000 won't burn the house down. Fucker doesn't need to go up in smoke, hollow you and the firefighters each a coast. Therefore, let's get back to how this thing works, along with installation by these three birds.
Yes, when I talk of electronics, you'll have to bear in mind that my knowledge is very rusty. Years of alcohol abuse has addled my brain power quite terribly, and I'm working with components I have to hand which may not be the best for the task. but it'll work, albeit there may be better ways to design something for the same function, so haters can hate, but it's done, it's in, the customer is happy, and you're a prick anyway. The first issue to tackle when using traditional intruder infrared sensors is how the buggers work. They tend to have 6 terminals, 2 for the 12V DC power, 2 for a tamper loop, and 2 for the relay output, which is normally closed. For this purpose, we can ignore the tamper terminals, which, if used as intended on a security system, would be wired as a physical series loop back to the alarm panel. Should some nefarious felon want to break in with the intent of defeating detection to rifle through your underwear drawer and grab you by the hairlooms, either by cutting the sensor wire or by opening the sensor itself, the tamper loop would lose continuity and get alarm bells ringing. Quite literally, as the panel would interpret this as an event it ought to report on. However, ignore and forget all that, as this project has nothing to do with anyone's underwear drawer, paedophile list, or some demented pervert trying to get his hands on your family jewels. So we can ignore the tamper for this presentation, as what we're interested in is the fucking relay output, essentially itself a switch which is normally closed. Like the tamper, this works as a loop which, if intact, has continuity which the alarm panel can detect and interpret as all being well. However, if that loop were to open circuit, either because the cable has been cut, the sensor has been smashed, or the sensor has detected movement and duly clicked open the relay contacts as designed, then the alarm, if armed, will know something is awry and start warbling away. Unfortunately for us, misusing these sensors as we are to control lighting rather than alarms, this behaviour operates opposite to how we desire. What we want is, effectively, for movement to turn a light switch on, but should we connect lighting directly to one of these assholes, it will instead illuminate quite happily when no movement is detected, because the relay contacts are normally closed, or on, when idle, and it will instead turn off when movement is detected. Using a PIR pulled out of my storeroom, I can show that here. You'll observe the LED tape is on until the sensor detects movement, where it turns the lighting off. No, this is no good at all. What we need is a way to reverse that whole shebang, so we'll have to pimp this bitch up with a NOT gate. A NOT gate is a basic logic function to reverse the output of an input. If the input is on, in this case 12 volts or logic 1, then we want the damn thing not on, that is to say 0 volts or logic 0. If, however, the input is off, then we want it not off, that is to say on. I hope you thick twats are keeping up out there, because if so, we can achieve not goodness thanks to an unhealthy amount of Strongbow and a few discrete components. In this arrangement, and with 12 volt applied to one relay contact, when the sensor has detected no movement, the relay is closed, so 12 volt pisses out of our sensor. We can feed this via a limiting resistor into the base of an NPN transistor, whose collector is on the same 12 volt supply, albeit via another resistor. The transistor's emitter pin is grounded on the negative rail at 0 volts. The sensor voltage appearing on the transistor's base switches the transistor on, the effect of which is to short together the collector and emitter pins. Because the emitter is connected to ground, our resistor now has 12 volts on one side and 0 volts on the other, therefore some current flows across the resistor and transistor between positive and negative, but the key thing for us is that the collector is shorted to the 0 volt rail, which is the opposite to the 12 volts we're spunking up the base. So we have successfully reversed our output with respect to our input. Should our detector sense movement, it duly opens its relay so that the 12 volt going into it can no longer come out of it. This now cuts the voltage to the transistor's base terminal, which causes the tranny to turn off, effectively open circuiting the connection between the collector and emitter. We still have 12 volts on one side of our resistor, but with no path to ground, that potential is also at the collector terminal, so again we have successfully reversed our output with respect to our input. On this job I'm looking to use 2 sensors, one at the top of the stairs for those descending, and one at the bottom for anyone ascending. Although the operating principle remains the same, we do need to make a change to the input stage by bunging in a few other components to add a second logic function to our NOT gate, for we shall also now require an AND gate. Ascending. 2 sensors mean we have 2 detection signals, one from each sensor's relay, depicted here with the other terminals now omitted to decrease the on-screen clutter. Both sensors need to be converted into one input for the transistor, so each now has a pull-down resistor and a diode, actually a 1N4148, but mislabeled as a 1N4001 in all these slides, thanks to a mix of Guinness and Strongbow consumed while I drew them. Although it ought to work either way, so let's ignore that. With both inputs at 12 volts, i.e. when no movement is being detected, the sensor relays are closed, and the 100k pull-up resistor is at the same voltage as the sensor 1 and sensor 2 outputs. As there's no potential difference, current instead passes from the 12-volt supply through both the pull-up and transistor input resistors and into the base of the transistor. As before, this turns the transistor fully on, the connector emitter junction is effectively short circuit, and the collector becomes grounded, which gives us our output reversed to that of our inputs, as we saw before. These are our two logic functions in action. Input 1 and input 2 being at 12 volts, or logic 1, means our output is not at 12 volts, but it is instead at 0 volts, or logic 0, and our lighting remains extinguished on no movement as desired. Okay, wise ass, let's reset and see what happens if we remove one input, say that of sensor 1, as though it's detected something lurking. In such an event, should a sensor click its relay open circuit, its output will of course no longer be at 12 volts. Here, sensor 2 still has its relay output voltage present, but a diode blocks any current path from that to the transistor, so while idle, it has no bearing on what will happen here, and it may be discounted. However, sensor 1's output, now being open, sees the current passing through our 100k pull-up resistor, suddenly finding a lower impedance path to ground via the diode and pull-down resistor. This drops the voltage at the transistor's base, which in turn open circuits the collector-emitter junction, once again cutting off the collector's path to ground, so that 12 volts is now presented at our output. Detected movement thus gives us a voltage we can use to turn a light on, which is not what we don't want from our NOT gate, should we wish to double negative the bastard. These additional components give us our two logic functions of NOT plus AND, or NAND, which sounds spastic, but is an actual thing. And if we look at how the NAND function works, we can see that anytime both sensors have closed relays and are farting out 12 volts, or logic 1, then the output which controls the lights will be off, because that output is not the inputs of A and B. If, however, one or both sensors detects movement, then one or both inputs will drop to a logic 0, with the result of the output not being a 0, therefore being on. Christ on a bike, and it's only going to get worse, because although we've cured the problem of the sensors being on when we want them off and vice versa, we have yet another issue in that intruder alarm sensors have no timer, and the fucking things will only operate whilst actively detecting motion. Should my valued customer, valued at least until they've paid the invoice, happen to pause halfway down the staircase, either for a breather, to examine a pressing text message, or because their hip hurts, then they may rather suddenly be plunged into darkness. Yet it takes but two more components to give us a basic timer that can hold the lights on for a little longer, they being another diode along with a fat capacitor. We will also require two final components to complete this lighting Frankenstein's monster, required for interfacing with our LED strip, and consisting of another limiting resistor and a beefier NPN transistor capable of handling the LED tape load, which is connected between the 12-volt rail and the collector. In this final form, whenever a sensor detects movement, we've already seen it switches the first transistor off, and with that transistor's collector rising to 12 volts, it now immediately switches the second transistor on. The collector emitter to transistor 2 short circuits and provides a path from 12 volts through the LED tape and to ground, causing our tape to immediately light up like a Christmas tree. The 12 volt present on transistor 2's base also quickly charges the fat bastard capacitor, which acts like a battery. When the sensor stops detecting movement, all too soon for our liking if someone happens to have paused on the stairs, transistor 1 turns back on, which means its collector is now grounded, and we lose the 12 volt input to tranny 2. Or do we? Because our charged capacitor now starts to discharge the 12 volts it's storing. However, the diode blocks it from spaffing the lot immediately back to the 0 volt rail via tranny 1, so instead it has to discharge its load up the open and willing base flaps of tranny 2. The capacitor's charge keeps the transistor 2 collector emitter junction short circuit, therefore the LED tape maintains its illumination, at least for as long as the capacitor supplies a suitable voltage, but like most of us, it won't take long for the capacitor to run out of spunk and wholly lose interest with the proceedings. As it discharges, so the resistance of the collector-emitter junction increases in sympathy with that diminishing input. The light output smoothly dims as the resistance rises, resulting in a slow fade out to the point where the capacitor is completely discharged. The collector-emitter junction is once again fully open circuit, and there's no longer a potential difference across the LED tape to light a goddamn thing. The nice thing about this design is that the lights come on immediately and in full as soon as movement is detected, yet there's a nice even aesthetic fade effect once movement has ceased for some 5 seconds or so. Hey, I told you it was a load of amateur crap. However, despite boring you with the particulars, I'm not even going to do it quite like that anyway. Oh, come on. It wasn't all for nothing. The same principles apply. However, I'm going to substitute some of the discrete components for an integrated circuit naturally native with the NAND nonsense. The output stage remains the same, albeit with a couple of different component values. But now on the input, I'm using a 4011 integrated circuit, which is a quad 2 input affair, meaning it has 4 NAND gates, of which I'll need but 1. Each gate has 2 inputs, which is fine as I'm only using 2 sensors. So although the last circuit was scalable and more sensors could easily be added, this one less so, at least not with this chip, although something like the 4068 single 8 input version could be used if you could find one anywhere. The 4011 chip does away with transistor 1 and all of the associated diodes and resistors we saw on the input side when using discrete components, save for the pull-down resistors, which remain in place to ensure that when a sensor cuts off its 12-volt output, the logic gate input is pulled low and not left floating. Otherwise, this works in exactly the same way, with either sensor going open circuit with a movement being detected, causing the output from the chip to both switch on the load transistor and charge the capacitor. It's this circuit the Saver 1000 has been built to. In both cases, the output transistor is a TIP102, which, with a heatsink, can handle the current of 5 meters of this LED tape, although on site we'll only be using 3 meters. In the end, I plumped for the chip over the discrete build because it seems to hold the lights on for longer with a smaller capacitor, and because I've built this circuit once before back in 2019, as blabbed about on my website, and where it remains in operation today. So I guess it can't be totally shit. Wait a minute, what the fuck? These sensors have a jumper that allows the relay operation to be reversed from normally closed to normally open? Oh, for fuck's sake. And what the shit? They also have a timer function to allow them to hold their output for up to 30 seconds on motion detection. Son of a bitch, I didn't need to build the fucking Saver 1000 at all. Why didn't I read these bloody instructions a week ago? Yeah, there you go. This particular sensor, made by Challenger, has inbuilt the functionality I'm busting my hump over via a couple of jumper placements. 2 things, however. First, the lights are very on-off. There's no aesthetic fade, which looks so bling. Second, even on their highest detection setting, they seem to take multiple hits before operating, which you find in pet-sensitive PIRs to keep the nuisance alarms down. But I think I'm still better off getting a traditional pair of cheap sensors and employing the Saver 1000. Especially now I've made the sodding thing. But it goes to show you don't have to get busy with a soldering iron for much the same effect if you buy the right thing. We're in a basement dining room, and here's Linda paying close examination to the Saver 1000. I reckon she's trying to steal its secrets and sell it to China. No need, no need. This video is going to explain all. Let me tell you the plan. The plan is to spur off that socket, which is on the opposite side to our stairwell. And here is said stairwell in question with Daniel upon it. And we aim to be lighting up the underside of this surface with our LED tape. What's that going to be? That's about 3 meters, something like that. The Saver 1000 can handle 5 meters, so the spur will come out under here, and that's where the Saver 5000 will be located. It'll be hidden under there somewhere, with wires going to our 2 sensors that are going to be mounted up high. There is a bit of a cock-up that Dan's made. Yeah. When these sensors were procured, where have they gone? I thought that they would come with a bracket allowing easy anglage so that we could point them where we want them to be, and it turns out they don't. They're fixed for directly on the wall or for corner use, which isn't ideal for us. So we're having to mechanically just figure out where we want to put them. There's one of the sensors now. So that's all we've got to play with. There's no bracket. These aren't the sensors I was going to use. I was going to use a couple of other ones, but...
Go cheap.
No, the ones I had, as I've probably already explained in this video, did the job without the use of the Saver 1000 at all, as it turned out. They had all that functionality built in, which took all the fun out of things. But I didn't like the way they operated. I just wanted the basic, plain old sensor. So I went for these. cheap, effective, they last forever, but no bracket. So we're wondering about putting one, there's some trunking at the top of the stairs, we're wondering about putting one fed via that trunking to catch someone descending the stairs, and then perhaps one near the corner of the banister there for those ascending the stairs. Linda, are you ascending?
What's the client's name? The gentleman?
Will. I think they're all upstairs.
Upstairs, not here.
No, all upstairs. So we'll have 3 cables to run. One to sensor A, one to sensor B, and one to the LED tape. I should stop yapping and aid young Danny boy with figuring out how we're going to get these cables into places, while Linda just checks that we're clear to cut off the power, because she's going to be removing this socket, performing some tests upon the circuit to make sure it's fit for modification, and then we're off.
Those of us who are serious about their work, these devolves, as opposed to those who can't even be bothered to charge their batteries mostly.
That's a brand new battery I'll have, you know.
Fine. After it ran out yesterday. And your second one was also flat yesterday, and Bosch.
I don't think you can blame Bosch for my
the Bosch is the
lack of battery charge.
DIY brand, Bosch. And DeVault for the professionals.
Well,
What?
that drill must be at least 15 years old.
Oh, really?
Yeah, when they first come out.
Yeah, mine's 10. But one of these is 10. I've got the impact.
Yeah, no, when was it? 2015.
Yes, that's exactly when I bought it.
And
Drill Talk with Dan and Linda.
2015, yeah.
this has got so hot when I was doing trailer floors, I had welding gloves on, like drilling 6mm screws into floor, through 31mm this hard flooring.
But it's still going. See?
Glowing.
If anybody wants to hire these two for a podcast, for some fascinating conversation. This is interesting because this is a plasterboard wall here, but it's solid on the other side. Linda, since you so diligently took that socket face off, can you take that box out? The dry line box.
Yeah.
Let's have a look at what's behind there. We've successfully managed to get our cable through
Well, hopefully.
and hole up here already, which will allow us to utilise that trunking. That's not doing too much at the moment. And then
Let's see if you can see that line.
Dan's trying to get a cable through for the LED tape. It's all mechanics, this, isn't it? Got to get past the mechanics. Oh, Christ. Hang on, let me turn this torch off here. I can see the light.
Yes.
You can see light, you're all right. So this wall's been studded off and plasterboarded. I thought we were in for an easy ride when I heard that it was a possibly a stud wall, but no, I'm going to have to drill through the brick to get to the other side of that. Oh well, 'tis what 'tis. Can you believe Linda won't drill without the correct PPE? What has the world come
No, it's
to?
not PPE. It's, what do you call it?
PPE?
Biffin. No, it's, biffinness.
Biffing brainwaves.
Yeah.
Your biffing brainwaves
I
can't take the
sensitive noise.
the noise of the drill.
Sorry about that.
Cool. Women in the workplace, eh, fellas? Eh?
Please give me,
The keys.
please.
Yeah, I'm not sure where I've just put them. Okay. There you go. Every hole's a goal. Oh, the perfect crime, Daniel. Making use of an existing trunking run there. Why, apart from the sensor itself, you would never know that cable was there. Star.
Parkside.
Parkside, bitch! What's that, Little or Rowdy? I can never remember.
It's little.
It's quite a funky thing.
Should be 3.
Parkside!
Yeah, Parkside, bitch.
Dan's having fun. But look at those stairs. The Savo 1000 has them illuminated. That's the idea, to illuminate the treads. I've just, obviously my moving has triggered the sensor, so we're on the sensors are off at the moment. There's no red lights on them. You can see the light is fading away, much like my patience for how the day is going. And as one tries not to trip over the tools and goes to ascend the stairs, as you can see, the lights come on. And they'll remain on while the sensor's showing it's being triggered. Linda.
Yes?
Stop moving. Everybody freeze. We're waiting. 5, 4, 3, 2, 1. Light fade should begin. Yeah. Fade. Fade and gone. And now, Linda, if you would like to ascend the stairs, you can be the model ascending the stairs. Oh, well, that's the most I've ever seen you move.
So
And there you go.
The bottom one's not picking it up at all. Should we turn it round the other way?
Christ on a bike, Dan.
He needs you, Dan. I mean, he needs the bottom step. That's what he needs.
It won't take me 2 seconds to do it.
You'd have to put a hole in the other
I
side.
just need my cable tie.
Oh, you'd have to put the hole in the other
Capitol's
side.
coming now.
Gordon Bennett, it's gone 1 o'clock. I thought we'd be done here a couple of hours by now and sitting down having lunch before our afternoon job.
Well, I think the trouble is, Dave, you overestimate how quick you are.
Underestimate how long any job will take. Right, so we've swapped that sensor around just to see if it gives us a little bit more coverage at the bottom of the stairs. I'm not sure we should have done that, you know, because we don't want it necessarily turning on and off as people walk past, but as they ascend the stairs, we want them to go on. Linda, would you like to go towards the stairs? Look, it's getting you right there now. Well, okay, we'll leave it like that. And if they think that it's too sensitive, then we know we can always just rotate that sensor around to
Do you like...
remove the sensitivity.
you just want some sensor tape, the tape you get for it, don't you? You just put a thin strip of it across there, across the sensor. Yeah, you know what I mean?
Tell him just...
Just Mr. Fucking, let's stick electrical tape on it.
Not electrical tape, you pikey.
He thought I was putting sellotape on something. When I was putting that, you know that Gorilla double-sided tape?
Yeah, but we don't need to be sticking tape on anything, kids. Right, I tell you what, that top one keeps on getting us from down here. We might have just got away with one sensor on this whole thing. I don't know what's chiming away in the background there. Is that what your farts sound like, Linda?
It wants plugging back in.
Oh yeah, plug
All
that.
the stuff's got the hump because that's unplugged.
What is that nonsense thing?
Not in here, Linda, out there.
Oh, it's one of their phones, probably.
is it?
Whose phone is this?
I don't know.
I'll take it to them.
Bottom sensor got a, top sensor got a. Right, and as she disappears in the way that she does, bottom sensor's gone off. Top sensor's gone off. It takes about 5 seconds. Oh, she's gone and woken up the top sensor again now.
Right, oh shit, there's all this fucking stuff. Just give me the view quickly.
I was trying to get the wonder. I wonder why I bother. There's our Savo 1000 under the stairs there. So we are coming in through the back of the FCU from the plug on the other side, and the Savo 1000 with the LED driver are contained within that twin patras. And look, I put a natty little label on there, so that someone in the future can look at that and go, what the fuck is this? Spiffing, don't you think? Gosh. So what we're saying to the Savo 1000, that's quite a bit of kit, don't you think?
That's fucking amazing, David.
I bet all the electronics goons watching this are spitting feathers right now.
Spitting feathers, does that mean they're not impressed?
Yeah.
But it looks beautiful.
It's probably a much better way of doing it.
And those are the clients are very happy with it.
Well, it all worked out. It all took a shitload longer than expected, and we've still got another job to do this afternoon. So let's get ourselves a little coffeeette.
Can I go home?
Boof on. Indeed.
Yeah, it's my fault. I made you do it properly.
I know, yeah. You're coming out with this again, you prick. Right. Coffee shouts. A new day, a new pub. We seem to be bouncing around some of the pubs around the area, don't we? And they always seem to keep closing or whatever afterwards. We're at the Somerville Arms,
Very nice pub.
Lillington Way, if you happen to be here. It's a grimy old day. I can't remember the name of the storm, but there's a storm going on. There's a storm a brewing. I can feel it in my, always feel it in my false testicle. Aye.
What?
I've got a wooden ball.
I don't want to know about your
Terrible
wall.
accident with a grinder some time ago.
No. I don't want
Whilst
to know
wall
about those.
chasing. Don't wall chase while naked, kids. Always wear your PPE. But here we are in the Somerville Arms.
Did you get one of those boxes?
Boxes?
A box, like a
Oh,
cricketer,
boxes.
a cricketer,
Oh, yes, okay.
or a ballet dancer,
Oh, yes, a jock strap.
a jockstrap. Something I don't know what those are called. Christy had a lunchbox.
Let's see what Father Christmas brings me this year. Almost the season, just a few weeks away now. It's a miserable November night out there.
Fucking hideous.
It's not even night, is it? Is it even 5 o'clock yet?
No,
42.
it's 16:41, and we're in the pub.
But we've had a day of
Fucking
dusty, brick
dusty.
breaking, and every time you've got to go out to the van, it's pissing it down with rain. So this is medicinal, isn't it? My cider,
Absolutely.
your double brandy, Cavoisier.
Cavassier. What do I say?
I don't say it, I just paid for it.
I worked hard today, though.
You worked very well today. Yes,
Thank you.
Yes. I'll give you that. You earned your pennies and your double brandy today.
Did I get a cup of coffee this morning? No. Anyway, should we move on? Am I being
No,
boring?
you didn't actually. No.
We're being
Oh, you
boring.
did. We went to Tesco Expo. Let's move on to the shout-outs because the battery's going to run out this camera any moment. So we're starting off with a Hall
Who is Andy Hills?
who says...
And he says, aha, someone does watch your new Tool Tuesday video.
Oh, I'm glad one person watches them. One person actually bought one of those mega
Yes,
things
the mega. It was
on
one
the
of the-
back of my videos.
Yeah.
Does that make me an influencer? Can I call myself an
Are you an
influencer?
influencer?
Someone bought it based on me showing it.
And although it's expensive, it's great. It does a good job.
We were using it on site just today. weren't we?
Yeah. Did you put your many finger balls or what?
Yeah, I got it quite dirty with my dirty fingers.
It was house bashing. Why have you started gurning funny faces at my company?
It just works. So when I'm near you, I find myself gurning. I can't think why. Moving on to SuperThanks.
No, I shouldn't say this. You'll probably cut it out. But you won't let me squeeze that thing.
You can't squeeze my spots. It's far too personal. We have to have boundaries.
No, but spots are outside.
Sorry, you don't squeeze my spots, and I won't squeeze your tits.
Spots have got to be different from tits. Come on.
Either way, this is a working relationship.
For fuck's sake, but okay, as a person, I can't look at someone's face without squeezing things.
Moving on to SuperThanks.
Okay, SuperThanks. So how many are there? 1, 2, 3?
Only 3.
Okay, only 3?
2 plus 1. 2 plus 1.
Fuck off, David. Right,
Before the battery runs out, the first one
quickly. Chris 220480.
rolls off the tongue.
Almanac? No.
No, hang on, he's a blue whore.
Oh, sorry. Are we all?
Is he a he or is he a she? Chris
We
could
don't
be
know,
a
no.
male or female now.
And the 3 blue halls. Shall I read all 3?
It's whore.
Chris 220480. Almac 56.
Hold on. You can't just rattle through these. They've paid for their time. Almac 56 has paid for that name to appear on the screen.
How long do I have to?
Oh, we can move on now. Plenty of time.
Almac.
Didn't pay that much.
Let's move on to Gadgetman 36.
Yes, good old Gadgetman 36. There you go, that's your time up as well. You had your moment. There it is. Monthly periods. I have the usual.
It says, buy me a
Fox Sports
Tampax.
buy.
What would you do? What would you do with the Tampax? Do you even know where Tampax goes? David? Are you alive?
Well, this really is running out of battery. Go rattle these very quickly.
Quickly. Monthly periods. Let's go. 1, 2, 3, 4.
Don't count them, read them.
I'm going to read them. Mr. Humbugs, Mr. Humbug, not plural. Tesco Junkie, J Sargent, Sir Jim Hook. Only there 5. Jonathan Blanky.
Right, they didn't get their time, so I'm going to read them again. Mr. Humbug, Saskia Junkie, J Sargent, Sir Jim Hook, Sir Jim Hook, Sir Jim Hook. Did you say so? And Jonathan Blankley. And that's all for this one because this shit Sony camera really is about to run out of battery.